Imagine a machine so versatile it can hover in place, move in any direction, and land on a dime. That's the genius of a helicopter. This airborne marvel is a masterpiece of engineering, standing out from other aircraft with its unique capabilities. Let's take a closer look at its key components. Most noticeable is the main rotor, a set of long blades spinning overhead that provide lift and allow the helicopter to ascend. Then there's the tail rotor, a smaller set of blades that counteracts the main rotor's torque and keeps the helicopter stable. Inside, we have the cockpit, the command center where pilots control every aspect of the flight. And beneath it all, the landing gear, designed to absorb the impact of landing and support the helicopter when it's not in flight. These components work together in harmony, making the helicopter an extraordinary feat of human ingenuity. Now that we have a basic understanding of a helicopter's structure, let's delve into the mechanics of its takeoff and landing. Taking off in a helicopter is not as simple as stepping on the gas. It's a carefully calibrated dance of physics and precision. Now let's delve into the art of takeoff, a process that requires an understanding of the machine, the elements, and the laws of physics. The takeoff begins with the pilot increasing the throttle. This isn't a matter of just turning a knob. The pilot must precisely control the throttle to speed up the main rotor. It's a delicate balance of power and control, as too much throttle can damage the helicopter while too little can prevent the helicopter from taking off. The rotor's speed isn't the only thing that matters, though. The pilot must also adjust the collective pitch control. This lever, usually located on the left side of the pilot's seat, changes the pitch angle of all the rotor blades simultaneously. As the pilot pulls up on the collective, the blades bite into the air more aggressively, creating greater lift. This lift counteracts gravity and the helicopter begins to rise off the ground. Now, you might think that the helicopter would start spinning in the opposite direction of the rotor due to Newton's third law of motion. But that's where the tail rotor comes in. It counteracts this torque and keeps the helicopter from spinning uncontrollably. But lifting off the ground is only part of the process. To move forward, the pilot uses the cyclic control, typically located between the pilot's legs. By pushing the cyclic forward, the pilot can tilt the rotor disc forward. The helicopter then follows the tilt of the rotor disc and moves in the same direction. This is the art of takeoff, a careful dance between power and control, between the force of the rotors and the pull of gravity. It's a process that demands not just skill but also an intimate understanding of the machine and the air around it. The helicopter is now airborne, a testament to human ingenuity and the laws of physics. Once in the air, the helicopter can maneuver in ways that no other aircraft can. With the freedom of the skies at its disposal, a helicopter is not limited to the conventional forward flight of an airplane. It can hover mid-air, move sideways, even fly backwards, defying the norms of aviation. How does it achieve this remarkable feat? The answer lies in the hands of the pilot and the controls they manipulate. The cyclic, that joystick-like control in the cockpit, allows the helicopter to move in virtually any direction. A forward tilt sends the helicopter racing ahead, while a backward tilt allows it to retreat. Sideways tilt? You guessed it, side-to-side movement. And the tail rotor control? It's the key to those breathtaking spins and turns, adding an extra dimension to the helicopter's flight. But what goes up must come down. So, how does a helicopter land? Landing a helicopter requires a delicate balance of control and finesse. Let's dive into the fascinating process of how a helicopter lands. This isn't just about pointing the helicopter downwards and hoping for the best. No, it's a careful choreography of actions, a dance between the pilot and the machine. As the helicopter prepares to descend, the pilot decreases the throttle. This reduces the power to the engine, which in turn slows the rotor blades. But slowing down the blades isn't enough. The pilot must also adjust the collective pitch control, a lever located on the left side of the pilot's seat. This control changes the angle of the rotor blades, allowing the helicopter to begin its descent. But the descent is only part of the story. The helicopter isn't a falling leaf, randomly spiraling towards the ground. It's more akin to a bird, able to control its descent and direction. And this control is all thanks to the cyclic control. The cyclic control is a stick that extends from the floor of the cockpit to the pilot's hands. It's like the steering wheel of a car, but with an added dimension. By pushing the cyclic control forward, backward or sideways, the pilot can maneuver the helicopter in any direction. This makes it possible to guide the helicopter precisely to the landing spot. But the pilot isn't just staring at the ground, hoping to hit the mark. They're also monitoring the helicopter's speed and altitude, adjusting the collective and cyclic controls as necessary. It's a constant balancing act, a dance of adjustments and readjustments until the helicopter is safely on the ground. As the helicopter nears the landing spot, the pilot must also account for wind direction and speed. These factors can affect the helicopter's stability, requiring further adjustments to the collective and cyclic controls. But with skill and experience, the pilot can compensate for these variables, guiding the helicopter to a smooth and safe landing. And just like that, a helicopter touches down, completing its journey through the skies. From takeoff to landing, every moment in a helicopter is a marvel of engineering and physics. We began our journey with a glimpse into the masterpiece that is a helicopter, intricately designed to defy the laws of gravity. We explored the marvel of its structure, each component working in harmony to make flight possible. Our adventure continued as we unraveled the art of takeoff, a process that requires a delicate balance of power and control. We then soared through the skies, experiencing the thrill and freedom unique to helicopter flight. The helicopter's ability to hover, ascend vertically, and descend with precision sets it apart from other aircraft. Finally, we touched down with a detailed look at the precision of landing. This delicate operation demands a keen eye, steady hands, and astute understanding of the physics involved. Next time you see a helicopter in the sky, you'll know just what it takes to get it there and back again. Thanks for watching.